Okay, Integrated Math 3 students in the B-Day classes. You are not watching me live on Microsoft Teams like you normally do, which is filmed over there in the live studio just 10 feet away. No, instead, you're watching me pre-recorded in my YouTube studio. Welcome.
Here's the story of Mr. Wade's evolution. I taught mathematics at this institution, but then came March. They postponed school. COVID-19 was playing us like a fool. I snuck back in and taught some AP, but they locked up the building and cut the AC. I got frustrated and wrote some sick rhymes. I filmed a rap video just to pass time. I started teaching lessons from my house in Brentwood.
Oh wait, you're not supposed to see my real house.
I started teaching lessons from my house far away, but I missed writing on a board every day. I talked to my friend Steve Smith, computer hacker. We had to find a whiteboard and he's no slacker. We looked around the city, but we finally scored. And now I'm back teaching from a dry erase board. Now we're off Schoology, every single grade. And that's the story of the evolution of Wade.
Now wait, how come you're not watching Mr. Wade live and you're watching me taped? Because, as you recall, Mr. Wade is recovering from surgery. No, not this Mr. Wade. I'm 3 days ago Mr. Wade. I'm talking about present tense Mr. Wade is actually recovering from surgery. You know, I wonder how present tense Mr. Wade is doing, because I haven't had the surgery yet. Let's check in on him. Yeah, that's about what I expected. Okay, so let's go into the lesson today of 5-3, and we are going to talk about Pythagorean triples. We hinted at this last time. Remember we did the 3, 4, 5? That's a classic Pythagorean triple, all right? So you know what? Maybe on your sheet somewhere off to the side, away from the problems, we can start a little list. So let's do a little list called Triples to Know. All right? Triples to know. Okay. So what Pythagorean triples do I want you to recognize so that when you see them on like the ACT or the state test, you can instantly recognize them and you can do the problem in like 5 or 10 seconds instead of like 5 or 10 minutes. Don't we like shortcuts? All right. The 3, 4, 5 is a very common triple, the most commonly used on the ACT. So you definitely want to know that one for sure. Let's explore more about like what is a triple again, right? What did we say last time and how does this happen? So let's say that you had A, 12, 13. All right, make sure you plug in the hypotenuse for C and you'll probably get the question right. Who's the hypotenuse? Do you see it? The longest side is 13. The hypotenuse is always diagonal across from the right angle. That is the C, okay? So these are going to be A and B right here. So let's set this up. A squared, okay? Put this on your papers. If you have the printout at home, you can put this on your papers. If you just have a clean sheet of paper, you can put it there, right? If you don't have paper, you can pause the video because it's not live, and then you can go run and grab some paper and a pencil. A squared plus 12 squared equals hypotenuse squared, 13 squared. Okay, now, let's challenge you to do this without a calculator because you have done this before. We've talked about 12 times 12 this year many times. 12 squared is 144, okay? We've even gone as high as 13, 14, 15, and 16 squared. Good refresher from the first semester. 13 times 13 is 169, and as a complete side note, 14 squared is 196. Anybody remember the switcheroo in the first semester where they kind of switch from each other and you can kind of memorize those in a package deal in your brain? Your brain would rather memorize one thing together than two separate things, by the way. So, 169, 196. Okay, now we don't need that right now. Now, subtract 144 from both sides so that we can get a squared all by itself, okay? A squared, cancel, equals, now probably if you're in an honors class or the honors contracted honors, you want to try to do this without a calculator, all right? You want to do 169 minus 144 in your head. If you do, have a calculator and it's handy and you're in the standard class, you can use it, but I would still challenge you to do it in your head, all right? Because you're all so smart. A lot of you can do this in your head. All right, if you subtract those, this is the way that I subtract numbers in math. I don't do the other version that they do back in elementary school and middle school. They do the whole like borrow and carry and all that stuff. I hate that stuff, okay? What I do is I add back to get back to the other number. This is what I do, okay? 144 plus 5 would bump me up to 149, plus another 20 gets me to 169. If you get that, great. If you like the old system, do it that way, great. Doesn't matter how you do it, just give me 25, okay? Now, a squared equals 25. Can we solve this? Perfect square, right? Take the square root of both sides and you get a equals 5. Why did that work out so nicely, Mr. Wade? Because we just discovered another Pythagorean triple that they sneak onto the ACT. All right? On the ACT, they sometimes use the 5, 12, 13. Let's put that over here on our list. If you ever see a 5 and a 12, you know it's 13. You don't have to show any more work. You already know the secret. You don't have to do this in the future if you know what the sequence is, okay? So 5, 12, 13, I want you to put both of these in your memory banks, all right? Okay, let's try letter B. So let's set this up. So we're going to do 8 squared first, plus b squared equals, and then the hypotenuse comes last, 17 squared. Okay, so you should definitely know, of course, that 8 squared is 64, so write that down, plus b squared. Now, we've gone as high as 16 squared. We've never gone to 17 squared. That's a new one, but you can do it on a calculator. 17 times 17 is 289, all right? And then, of course, we have to subtract 64 to get it away from the b squared, and you end up with b squared equals, and then, yeah, you can put this in a calculator, or if you're honors, of course, I would challenge you to do it without a calculator, because we do these in calculus without calculators. 289 minus 64, all right? It's going to be 200 and something, and you could say 4 plus 5 gets me back to 9, and 6 plus 2 gets me back to 8, okay? And you should get 225. Now, that is a perfect square we have done this year. Matter of fact, we were just talking about this earlier. What were we saying? We were saying 13 times 13, 169. 14 times 14, 196. 15 times 15, 225. That was way back in the first semester. And 16 times 16, 256. That's about as high as you'll ever have to go right there. Unless you want to memorize the bonus 17 squared is 289. That'll make you even smarter than the average student. But that's a good list to know right there. So I do want you to recognize in this class, in honors and standard, that 225 is actually 15 squared. So that is a perfect square. B equals 15 is the missing side. All right, we can put that in the drawing too. There it is. So wait a minute, that worked out with 3 perfect whole numbers, no square roots in our answer. That's another triple. 8 and 15 just happened to work out in the Pythagorean theorem to give you an exact 17. The ancient Egyptians, they knew about this one too. It's the 8, 15, 17 Pythagorean triple. Known fact. So in the future, if you see an 8 and a 15, or maybe there's an 8 and a 17 there, or a 15 and a 17, you know what the extra side is. So that's one of your triples to know, all right? There are really only 4 major triples I would ever want you to recognize. That's it. So let's see. We did 3, 4, 5. We did 5, 12, 13. We've got 8, 15, 17. We've got one more to do in letter C, and then we'll have a little adventure here. So now we've got a B, a 24, and a 25. Okay, so we could do 24 squared plus b squared equals 25 squared. Remember, the hypotenuse has got to go last or it won't work out correctly, right? All right, these numbers are way too big to do in your head. You can use a calculator for this, okay? I happen to know these because, of course, I do these all the time as a math teacher and a mathematician. So 25 times 25 happens to be 625. 24 is my favorite number, by the way. And 24 squared is 576. So I definitely know that one. 576 plus b squared equals 625. All right. Subtract 576 from both sides to get b squared by itself. Okay? So write that down on your notes there. And we're about to find something amazing. You can go ahead and use calculator for this one. That's fine. 625 minus 576 happens to be exactly 49. Oh my gosh. Do you see what just happened? It's a perfect square. This must be another triple that even the Egyptians knew. So, if you take the square root of both sides, b equals 7. There's the answer, but triples to know. Let's put that back in the picture. 7, 24, 25 is a triple that the human race has known for almost 5,000 years. It's been known, and now you just discovered it for the first time. 7, 24, 25. These are the 4 main triples that they put on the ACT. They hide them all over the place, all right? We use them in calculus. We use them in pre-calculus. We'll have them on the state test in Integrated 3. We'll use them for other things in Integrated 3. In fact, I would say this list is just as important as knowing your perfect squares list that we talk about all the time. So I'd say this is one of the top 2 or 3 things I will ever show you right here, okay? Pythagorean triples. In fact, I have many former students who have told me that list of triples, Mr. Wade, that changed my life. Thank you for showing us that because I saw them all over the ACT. All right, now we go to letter D. So letter D, we've got 15, we've got 20, and we've got blank. Okay, let me show you how to use these triples to your advantage. Long way, 15 squared plus 20 squared equals c squared. That would be the long way to do this problem, and it's going to take some work. If you're good, you can solve this problem in about 10 or 15 seconds maybe. Let me show you the shortcut, okay? Let's say you're taking the ACT and it says 15, 20, C. Okay, here's the secret. Mr. Wade, is this another triple today? It is another triple, but it's not one you have to memorize. Don't add this to the list. You don't have to memorize this one. You can get it by just knowing these 4 triples right here, okay? So let me show you something. All right, shortest side is 15. Second side would be 20. And the longest side would be the hypotenuse, which will say question mark. All right. Do you notice anything in common between 15 and 20? Do they share something? They both have a 5 that goes into them. It's kind of like doing a common denominator or doing common factors or that kind of thing. If they both have a 5, factor the 5 out. Okay, let's put a 5, parentheses. 5 times blank gives me 15. Wouldn't that be 5 times 3? Kind of like the distributive property, right? 5 times blank gets me 20. 5 times 4 gives me 20. Oh, do you see it? 3, 4, blank. Wait a minute. This is a known triple. It's on our list. You see what they did? They snuck a 3, 4, 5 in there, and then they took a number and blew it up a little bit bigger. But at its heart, it's still a 3, 4, 5. So this is what you can do. Take the 5 out, look at the real truth, and it's probably going to be one of these 4 every single time. For sure in my class it's going to be, because those are the major 4 ones right there. So the last thing you do is you realize it's a 3, 4, 5, so you pencil that in there because you know your triples list. Now take the 5 and multiply it back in. 5 times 3 is 15. 5 times 4 is 20, so it's working. 5 times 5 is 25. Final answer, c equals 25. And yes, you can get to where you can do that in 10, 15, 20 seconds instead of like taking 5 minutes to go through the big hassle right there. Okay? Now, is 15, 20, 25 another Pythagorean triple? It is, but don't memorize it. Just know your basic 4 and you can find others that are called the multiples of triples. Okay? Now, as we go to our last problem here, the history of this is actually quite fascinating. The history of how the whole thing was discovered and the other discoveries that have been made since then. So, you know what? Let's take a quick little history break and let's just figure out how all this came together.
In 2000 BC, Pythagorean triples were first discovered by the ancient Babylonians in the Middle East. They were used for architecture and discovered by trial and error. Around 550 BC, the Greek mathematician Pythagoras discovered the Pythagorean theorem for right triangles. But it took 150 years until number 11 ranked Euclid actually made the proof of the theorem. Around 400 BC, famed Greek philosopher Plato actually found a formula that generates infinite random triples, but not every possible combination. But it wasn't until November 28, 1997, that a middle school math teacher at the age of 27 found the formula that generates all possible Pythagorean triples in the entire world.
All right, let's do letter E. So, this is a Pythagorean triple. 10 blank 26. Are you supposed to memorize it? Nope. You're just supposed to know these 4 right here. Okay, let's see if we can find it. Now, long way, 10 squared plus b squared equals 26 squared. That's going to take you some time. Shortcut, 10 b 26. Do 10 and 26 have anything in common? Yes. They both are even numbers. That means 2 goes into both of them. Factor out the greatest common factor. This is why they taught you in middle school about GCFs, because they come in handy for moments like this. Take out the 2, but think distributive property in your head. 2 times blank gets me back to 10. 5. 2 times, well, we don't know what b is, do we? Okay, b's the question mark, right? Okay, to be determined. 2 times blank gets me back to 26. Double 13 is 26. Okay, we've got a 5 blank 13. I wonder what, look what's right across from it. 5, 12, 13 is a known triple for the last 5,000 years. You know it. The ancient Egyptians knew it. Everybody knows it. Well, most people know it. Well, actually, very few people know math in the real world, but you do. 5, 12, 13 was hiding inside there. Now put the 2 back in. 2 times 5 is 10. 2 times 12 is 24, Mr. Wade's lucky number. And 2 times 13 is 26. It works. 10, 24, 26 is a known Pythagorean triple. It is just double the 5, 12, 13. And we discovered it. And the ACT hides it in there. And if you see it, you can go, oh, I know what it is. 24, final answer. Okay? That's how you solve these super fast. I'm telling you, triples, life-changing. Now, integrated 3 students, I want to show you an interesting example of the add back method because I've been talking about that in class, right? So the add back method, okay, if you had $10 and you spent $7.80, well, you expect change back, don't you? Of course. So the cashier hands you your change. Did you know that most Americans without a calculator will write $3.20 for this? Why? Why do most Americans write that? And probably most people around the world without using a calculator? Because your brain is doing 10 minus 7 is 3. But wait a minute. That's too much change, isn't it? Here's my add back method. If I ever did 10 minus 780, I would say $7.80 plus how many cents to get back to a nice whole dollar amount? Wouldn't 80 cents plus 20 cents make it a nice $8 now? You see it? So $7.80 plus 20 cents makes it $8. How far are we from 10? 2 more dollars. You see that? Okay, so the add back method eliminates that mistake completely. If you add 20 cents, you bump it to $8, you add 2 more dollars, you will never make that mistake. But you would be shocked at how many people cannot do that because they're trying to subtract instead of add back, and their brain tells them 10 minus 7 is 3. Matter of fact, from one of my favorite reality shows, Chrisley, oh my goodness gracious, and those were 2 college students making that mistake. They should know better. All right, now you know better. Okay, I got a big surprise for you. We are going to go around Nashville and we're going to seek out some of the steepest streets, because weren't we talking about that in class? We were talking about the steepest road in Nashville. We were talking about the steepest road in Pittsburgh, New Zealand, Wales. Let's take a quick little tour just for fun, and then at the very end, if you click on the bonus video, you can see where I took a road trip out to find the steepest road in all of Middle Tennessee, which is a very broad area, which is basically 1/3 of Tennessee. All right, so let's take the tour. Let's go.
Mr. Wade is driving all over Nashville today to try to find for you the 5 steepest public roads in all of Nashville. We're going on a journey, an adventure, and we're driving over rough roads. We're gonna do this. Let's go have some fun. Well, as you can see right over my shoulder, we are on South Hillview Drive right now that we talked about in class. It is an 8.4 degree angle at its steepest. Now consider this, on the interstate, the steepest that a tractor trailer can drive up is about 5.1 degrees. This is 8.4. I mean, if you look down this hill right here, it is just tremendously steep. So if my car started rolling right now, I'd be in trouble. So as learned in class, South Hillview Drive is the steepest overall from top to bottom. But what about a little 10 to 20 foot section of pavement? Those can be even steeper on certain roads. So this one, 8.4 degrees max, makes it the 4th steepest little section of road in all of Nashville. Guess who's number 3? The one right next to it, Hillview Drive. Goes right up that way. All right, that's the 3rd steepest. It goes up to 8.7 degrees. This is extremely steep. Now, we're gonna go chase down the 2nd steepest piece of pavement on a public road in all of Nashville, and we're going all the way across town now. Now we're out in Donaldson on Fernbrook, which is the 2nd steepest public road in all of Nashville, breaking up the monopoly of Brentwood and the monotony. Here we are, this little stretch right here is 9.3 degrees, very steep angle. And this was actually discovered by one of our integrated 3 students, JJ Thomas, who found it for me and measured it, and I came out here to shoot it as number 2. But what is the number 1 steepest piece of a public road in all of Nashville? Let's go back to Brentwood. Well, this is it. This is your max. Not for the overall road, but for this one little section right here. This section is actually 9.4 degrees steep for an angle. Where is it? It's right back in Brentwood. It's East Hillview Drive, like 100 feet from where I was a second ago on South Hillview Drive. So this whole area right here, this is the number 1 steepest public road in the city of Nashville. But guess what? We can do even better than that. You know how? What about the steepest parking lot in the city of Nashville? Well, we're headed there right now. And I'm gonna change my shirt into a blue shirt just for the fun of it. Well, it's starting to get dark, but we are here at the Marathon gas station right next to Nashville School of the Arts, and this is it. There's my car right there. This is the steepest piece of pavement, even though it's not a public road, in all of Nashville right here. This is the max. I mean, this is it. Just look at this slope right here. It's absolutely insane. It's a little more than 14 degrees steep, so this is, you can't beat this. I've looked all over town. This is number 1 right here.
But going back to public roads, is there a public road in all of Middle Tennessee that can beat East Hillview Drive? Well, if you want to see Mr. Wade's bonus adventure on where I actually went out and found a steeper road in all of Middle Tennessee an hour and a half away, click on the box, click on the link, and you can see a little bit of bonus footage today.